Alright, this is the 3M mixed university college level grade 11 math. Unit 1, Chapter 1 review. So Chapter 1, and it's quadratic functions. Quadratic functions. Focusing on the fun in functions. I'm going to put the fun back in functions. The joke also works with funerals. Doesn't go over as well at a funeral though, just so you know. Alright, so what I'm going to do is just whip through the Chapter 1 review. This is on page 54 of your text. You should be doing the review and the practice test. I might do a practice test question or two as we whip through it. So if I look at the questions, we start with number 1. How do you know something is a function? In general, how do you know something is a function? A function is a relation, and it's a special relation. And it's a relation where each independent variable is seen only once. So each independent variable input value gives one output value. So I talked about time a lot for that. So when you have a distance time graph, for example, something like this, you never have more than one time at all in the graph. Which makes sense because when you throw something in the air or you monitor something over time, time always moves forward, it doesn't go backwards. If it did go backwards, so if it's something like this, then you would have something that would fail, a graph that would fail the vertical line test, and that's one way you know if something is a function. And that's really the only way you know something is a function. If it's an equation or if it's a graph. If you have a series of points, what you look for is a repeated x value. So this is fine. The fact that the 8s repeat are fine, but the fact that the ones repeats isn't. So we don't want a repeated x value for a function. So if it has that, it's not a function. So let's look at function notation, and this is number 2, and I'll do the hardest one. I'll do C, 2C. And what you want to do here, this is f at x is x squared minus 10x plus 25, and in 2C I want f at 1/2. What you'll just do is anywhere you see an x, you'll sub in a half, so you have 1/2 squared minus 10 times 1/2 plus 25. That's a 25. And that's a quarter. 1/2 times a half is a quarter. Subtract 5 times a half is, or 10 times a half is 5. Plus 25. So now I have this. This is a bit easier to do, but I'm going to pretend the fractions aren't that easy. You could work this out. A quarter minus 5, so you'd have minus 5 plus 20 is plus 25, is plus 20. Subtract a quarter, get you 19.75 or 19 3/4. But let's pretend it was a fraction that was harder to do. What you would do is change all of these to quarters. So I have 1/4. I have 1/4. I have 5 over. So what I'm going to do is multiply this by 4 and this by 4. Remember how to add numbers that aren't fractions. You're going to change this to 20/4. And then 25 times 4 is 100. And then you'd add this up together and say 1 minus 20 is minus 19, plus 100 is 81/4, which is fine, or you could take it to the next level and say it's 20. Oh, what just happened there? 20 1/4. And I think I said it was 19 over here. So here, let's do this one again. Right, 1/4, subtract 5 plus 25, minus 5. Deal with this first. Plus 25 is plus 20, plus a quarter is 20 1/4. 20 1/4, which is the same as this. Okay, so that's that. That's function notation. Domain and range. Anytime you do domain and range question, what you're going to want to do is, I'll get another slide here. I forgot how to do this. Is graph it. So if you want domain and range of something like, we look at a parabola opens down as vertex is located at minus 5. At minus 5, 10, so minus 5, 10 is over here. Come on, pen. Minus 5, 10 is my vertex over here, and it says that it opens down. What you want to do is sketch anything before you get to domain and range. Domain and range, domain is all the x values, so the x values here, most parabolas, or any parabola that opens up or down, you're just going to have this. The domain is all the real numbers, and the range is going to be all the real numbers because we have a line. And what you're going to do, though, is you're going to notice that you have a maximum, and the maximum here is 10. As high as you can go is 10. So that means y has to be less than or equal to positive 10. Can't get any bigger than 10 there. So that's how you get the range. If you want to look at 1.3 now, quadratic function or not, so 1.3 on the review, the first part says, is this a quadratic function? At number 7, what you're going to do is look for x squareds or anything squared, t squared, so an a. For example, you have t and then you have t minus 3 all squared. If you foiled out, what's going on there? If you fold out this, you would have it, you end up with a t squared. So if it has a t squared or a squared, then it is quadratic. And then b is in c is, how do you know a table value is quadratic? You look for first and second differences. So for example, in the first one here, I have minus 2, minus 1, 0, 1, 2, 3, 9, 6, 5, 6, 9, 14. And I look at the first differences. First differences, how do I go from 9 to 6? I go minus 3, then I go minus 1. I go from here to here, from here to here I go plus 1, from here to here I go plus 3, from here to here I go plus 5. That's first differences. First differences were the same. I would have a line, but they aren't the same, so I keep going. Minus 3 to minus 1, how do I get there? I go plus 2, plus 2, plus 2, and plus 2. So how do I get this plus 2? Slowly, I can go minus 1, minus 3. So you take this term and subtract this term. That's minus 1 plus 3. That's plus 2. And you do the same thing each time. Because second difference is the same, I do have a quadratic. 2, number 10. Number 10 is a good one. Sketch and label this. Well, I'll do C10C, for example. How you would be expected to do this is to draw the vertex and then do the step pattern. I don't have graph paper here, so the step pattern is going to be a little strange, so I'll show you though. So here I have minus 4x plus 2 all squared plus 8. First you got to get the vertex, and the vertex is minus 2 plus 8. So this guy here, you're going to change the sign, leave that sign here. So change the sign in front of the 2, negative 2, and then leave the 8. So minus 2 plus 8 over 2. So over 2 up 8. There's my vertex, minus 2, 8. And my step pattern is going to be minus 4 times 1, 3, 5, which is going to be minus 4, minus 12, minus 20. And I don't really care about the 20, but I'm going to go over 1, down 4. So I plot that, and then I'm going to go over 1, down 12. And then I draw the mirrored points. Now, you would have a graph paper on a test, so your point's going to be more exact than mine. Okay, but that's how you do it. Step pattern. After the vertex, there's your vertex, and then your step pattern dictated by whatever A is. We need to play Candy Crush. I might take a break. I'm just kidding. Write an equation for the parabola that satisfies each of the following. These are kind of cool. And by cool, I mean math cool. So I have a vertex of 10 minus 4, and it's congruent to, or 10 minus 5 is congruent to y equals 3x squared. Congruent means that it has the same shape. It has the same shape, it has the same step pattern. If it has the same step pattern, it has the same A. So I'm going to start off with 3. Okay? And if it has that vertex of 10 minus 5, then I know that if it's x minus 10, again, you got to change this sign, minus 5. I'm all done. So minus, congruent to that, with no x-intercept. So let's plot this real quickly. If it has a vertex of 10 minus 5, I'm down here somewhere. And if it opened up, I would have a couple x-intercepts, so it's got to open down. So how do I make it open down? Well, I throw a negative there. So congruent means same shape. So it's still the same shape as y equals 3x squared, but it's actually flipped. So, and that's how you know it's negative, because there are no zeros in that guy. Let's move to the next one. Let's not do that. Let's skip to which one do I want to do for the practice test? So page 57 in the practice test, 10. So if I have this, for example, in C, h at x, doesn't matter, h at x is equal to negative x plus 1 all squared minus 1. What's the vertex? Well, the vertex is going to be minus 1, minus 1. I'm going to change this sign, and don't change that sign. So there's your vertex. Transformations for number 12. If I want to talk about the transformations for D, for example, I have minus x. That's right, minus that's minus 3 all squared plus 5. What's going on here? Well, this means that I'm reflected in the x-axis or flipped in the x-axis. There's no vertical stretch or compression. If it was a big number, it'd be a vertical stretch. A small number would be compression. And then I have a vertex of 3, 5, which means that I've gone right 3, up 5. So you'd say flipped or reflected in the x-axis, left 3, right 5. Look at C, for example, where you have y equals 5x plus 1 all squared minus 5. You would also include there, because the 5, it starts with a 5, that you'd have a vertical stretch of 5. Other things you're going to be asked to do is write domain and range after you see something graphed, or just after you're given the equation, sketch them, and then go ahead and give the domain and range after the sketch. And that's about it. So that should get you ready for the test. Good luck.